Welcome everybody to another of our 2016 webinar series. Tonight we're bringing you one titled Give Me 5, and we're breaking new ground tonight that we have 3 presenters to share information with you tonight, each taking a very, very different approach to what they're going to show you. So let me introduce them to you, and okay, what's happening here. The first one would be familiar to you all is Brian Lannon. He's a very experienced T-Cube instructor from Victoria, and we have a couple of Queenslanders, Melissa Hourigan, colleague of mine from way back here in Queensland, and Stephen Broderick. I believe, Stephen, is this your first webinar as a presenter?
Second.
Second, right, okay.
Yep.
So, good evening everybody, and welcome to the broadcast. Just a couple of little housekeeping announcements. During the presentations, you have the opportunity to use the questions and chat windows, and you will see while you're watching my screen, you should see a green tab at the top of your screen, and if you pull it down, you've got the opportunity to view the chat window or the question and answer window. If you are using those, would you direct your chat and your questions to all panelists, not necessarily the host as you see over there, but to all panelists, so that each of us will be able to see it, and while we're not presenting, we'll be able to perhaps sort out an answer and be able to respond to you at the first opportunity. So both questions and chat to all panelists. So without too much more, we're going to start. Brian's going to give you an overview of an activity that he's written, which is the title for this webinar, which is called Give Me 5, and that's available on the Senior Curriculum Inspired webpage. Stephen's talking about something rather different, a virtual online community called the Islands, and this has got me very excited to participate in this webinar tonight. So I'm not going to say any more about that, but leave it to Stephen. And Melissa's looking at some of the STEM behind health activities. This presentation will be available at the conclusion of the webinar, and links to the various activities are included in there. So if you don't get a chance to make note of them during the presentation, you will get a copy of or a link to this resource at the end of or a couple of days' time, and you'll be able to visit these sites. So without any further from me, I'm going to hand over to Brian to go through the first session of tonight's webinar.
Fantastic. Thanks, Jim. And just while I'm getting the ball here and sharing of the screen, I'll just explain that the idea for this evening's webinar came out of an activity package that I've written for the website, the Australian Texas Instruments website, called Senior Curriculum Inspired, which only launched last year. There's the link to it. And if you don't have that link, if you simply Google Texas Instruments Australia, you will find the Texas Instruments Australia webpage. And one of the main links from there is webinars. I dare say you found that one already. And another is Senior Curriculum Inspired and Australian Curriculum Inspired. In each of those, you get a package of goodies. And let me show you some of that. In a downloadable zip file, you get a worksheet for students. So this is the one on the left here, Give Me 5 student worksheet, and a set of teacher notes, which includes the answers. Now, basically, this is the same as the student worksheet, but the red parts written in are for teachers only. Comments such as references to the national curriculum, and teaching tips, and as I said, the answers to the questions along the way. The third thing that you'll get in your activity package is a TNS file or two, and this is one that I wrote for this particular activity, which I entitled Give Me 5. It's not a particularly complicated activity. It simply is a focus on 5-figure summaries. Here is the TNS file, and I've just done what's fairly straightforward to put into a calculator page into a lists and spreadsheets page anyway. But I've just got it all set up so that students, and remember, students are allowed to take TNS files into exams. So further math students do not have to clear their calculators for the exams. They can take this file in with them, and for that maybe 1 or 2 questions that they will get on 5-figure summaries, they can just open this file up, and here it is. So it's basically a list of data.
Can I just interrupt there? For those teachers that are listening to this that are in Queensland, obviously our rulings are different with that. Often it is a case of our students have to clear their calculators before they go in, or they have to be in press-to-test mode. So just being aware that in the different states there is different rulings on what they can and can't take into the calculators, on the calculators into the exam, sorry. Sorry about that, Brian.
Terrific. That's fine. Thanks, Melissa. So bad luck for those Queenslanders. That's just how it is. So nevertheless, this of course can still be used as a teaching tool and a learning tool and a study tool for students. So it's the list of data. Students will have done this where they've entered data into a list and they've brought up statistical summaries on the same page. So you see my data are the numbers 1 through to 6 there, 1, 2, 3, 4, 5, 6. The mean of that is 3.5. The sum of them is 21, etc. If we look down here, you can see the 5-figure summary. Okay. The 5-figure summary, of course, is also reflected in a box and whisker plot, which in this case is perfectly symmetrical, as you might expect for those numbers. And I've added a couple of other things in later pages, which I'll show you shortly. Walking through the student worksheet, I've taken it right from grassroots. First of all, you see here I've highlighted Year 11 and Year 12. They do need to know this in Year 12, but this would more likely be introduced at Year 11 or even Year 10. So this activity, I know I've certainly used it with my Year 10 class. I refer to the 5 figures as the Fantastic 5, and really introducing this at a very, very basic level. Starting, let's consider a data set of numbers 1, 2, 3, 4, 5. And my questions were, okay, and you see I've got in brackets here really easy ones. What is the minimum value for this data set? Okay, they should be able to find that without too great a difficulty, but we're then going to call that min x, and so on. And the middle value, median x. Quartiles a little bit more involved, and an important thing to note, and I put that in the teacher notes, is to note that for the calculation of Q1 and Q3, we do not include the median. So note that the median is excluded from calculations of Q1 and Q3. I have actually seen statistical calculations done differently than that, but this is the way it's done, I know, in the Victorian further maths curriculum and also on the TI-Nspire calculator. So students are asked then about measures of spread, and we talked about the difference of having to find a measure of centre and a measure of spread, and the difference between those two sorts of things. The fact that a measure of spread could be either range or interquartile range. They're asked to calculate those things from that set of data. Then they're introduced to the automatic calculator for the 5-figure summary. So from their worksheet, they're instructed to open the TI-Nspire file, give me 5, and as it is packaged, they will have the data 1, 2, 3, 4, 5 on the first page. So not the 6 figures I've got here, but just 1, 2, 3, 4, 5. I'm just going to delete that one. So notice when I did that, the statistical summary immediately adjusted. That's now the 5-figure summary. That's the corresponding box plot, or box and whisker plot. And what I've also done is I've added in on the third page, into a dynamic notes page, these figures out separately. So the range is calculated. So see, that's the maximum value minus the minimum value, and the interquartile range. I've listed the 5-figure summary in one set here, so that's our fantastic 5, and I've also individually listed them. So it's a double emphasis for students to say, you know, what is the Q1 value? There it is. Where does that rest within the 5-figure summary? It's the second figure in the 5-figure summary. Back into the worksheet. I'll go to the teacher notes here. Into the worksheet, I then asked students, okay, now try computing the using the automatic calculator for the 5-figure summary for the data set 1, 2, 3, 4, 5, 6. And they see that this is the result here. We still have 1 as the lowest figure, 2 is Q1, the median is 3.5 or 3.5, and you can see Q3 and maximum value. So I then ask, well, okay, we've tried a couple of data sets here. What would be a data set where the 5-figure summary are all integer values, those whole number values? And of course there's many solutions to that, but the simplest, and the one that they're most likely to find first, is 1, 2, 3, 4, 5, 6, 7. And there you see the 5-figure summary. So as you can see, it's dealing with really simple figures, but the idea is to emphasize to students how this 5-figure summary idea works. It's something that I know in the Victorian exams they will get at least one question on. And so that's a mark pretty much guaranteed if they get this idea. So I extended it to say, can you find another such set? Of course, there's various ways to do that. And I've got a note here that when the data set is changed, then the box and whisker plot will also change, but there may be a need to rescale it so that you see it on your screen. So zoom data from the menu is required for that. I'll just try these figures. What have I got? 2, 4, 6, 8, 10, 12, 14. Let's go to my calculator. Here's the data. So I just simply type over the data. So I'm going to go 2, 4, 6, 8, 10, 12, 14. And you saw each time I pressed enter, the statistical summary changed. Okay. The box and whisker plot will have also changed, but it's off screen because I've got higher values here. So to see what's going on, I go to, there's more than one way to do it, but menu, Windows Zoom, Zoom Data will change the parameters for that window so that my data and that high value of 14 are all visible. Okay, so really, really simple numbers. You know, you could use it earlier than Year 10, really. But the idea is just to ensure that students understand this, because we know, I can tell you I know in Victoria my students get questions on this in the further maths exam. If they know it, there's a mark. The other thing that they're going to be asked about, and certainly they'll need to address if they're doing a report, is the idea, I don't want that anymore, is the idea of skew. And I'll just jump back into my worksheet here. So far we've looked at symmetrical box and whisker plots, but what if it was a little bit squashed? What if it was changed in some way? So we talked about the idea of shape and skew. Now it's interesting with this, you can actually grab values on the box and whisker plot, drag them, and it affects the actual data. Watch this. So if I grab, say, here, so I've grabbed on the top end of the whisker and drag that to the right, You see I've skewed that to the right, and that's called skewed to the right, or positive skew. If I go back into page 1.1, I see what's happened to those data. Remember, the highest value was 14 before. It's now 15. You'll notice, however, that the lower values, including the median, remain unchanged. So it gives a really nice connection between the visual and the actual values. And it can also be checked, of course, with that dynamic notes page of the individual values. Further into the worksheet, bring that up. So the questions, if they look simple, they're meant to be. That's the whole idea. Just link them through it. Here's one where students are simply asked, connect the picture, the box plot picture, to the name, symmetrical, positively skewed, negatively skewed. They need to use that language in a report of univariate data set on our exams. And I've also got them to observe how the mean relates to the median. So that's a question there. That you're looking at the teacher notes there with the answers. On the student worksheet, it looks like this. Okay. Further into the student worksheet, I talk about this idea of outliers. Once again, something that they need to comment on in a report. And so what I've done is I said, restore your data set to the figures 1, 2, 3, 4, 5, 6, 7, and now replace it. Replace now we didn't add in an 8th value. So after the 7, I want to put in an 8th value, and let's make that 15. And what's going to happen? Well, when we get a picture of that, it looks like this. The 15 sits way out on its own as a dot on out to the right of the rest of the show. And so that's an example of what's statistically referred to as an outlier. But would 14 be an outlier? What about 13? What about 12? So what is, in fact, the smallest number that would not be an outlier? So exploring that idea leads to the notion of there's got to be some marginal value, let's call it a fence, whereby a value is considered to be, it's close enough to the rest of the stuff that we're going to call it part of the main body of the data and not an outlier. Is this just done by an estimation? No, it is in fact, although certainly it can be done by often looking at a data set, but it is exactly statistically defined. And this is part of the study design, as I actually said in the teacher notes at the start, that from the study design we've actually got to address these things here. So that's actually from the National Curriculum Statement. So definition of lower fence, definition of upper fence. I'll just show you what I've done here on the calculator. So I've calculated the fences on a dynamic notes page, and then I've introduced a final page that shows the fences being calculated. So it shows an upper fence and lower fence. That data aren't the best for it. Let's go back to my 1, 2, 3, 4, 5 through to and finish with 15. So here's my values: 1, 2, 3, 5. And remember, I was doing that last one was 15. So that will pop up as an outlier. But let's take a look at the fence for that. And that's what's happening here. So I've calculated the upper fence, and here it is here. So what's that? It's going to be 12.5. So it's showing the upper fence, and actually if I drag this back, you'd see the lower fence as well. So both are calculated. So students get to work on the worksheet to see how that's calculated, and they come down to the last part of their worksheet, and they get to check that against what's happening on their calculator. So simple activity, probably worth no more than one lesson, maybe 2 at the max. But if you've invested that bit of time, it's guaranteed to be asked on the exam, and I would hope that after doing this lesson they'd be guaranteed to get the mark, or marks. That's all I have on that, Jim. I haven't got the applications, the actual contextual-based applications, as you may be wanting to switch across to Stephen at this stage. Stephen
Thanks, Brian.
Stephen has some great stuff on this.
It's an interesting little comment, Brian. I once heard, Brian, that somebody asked, what's the guy that came up with this Tukey, why did you use 1.5? And it was profound mathematical significance. He said, well, 1 wasn't enough and 2 was too big, so I used 1.5, and that's what it's become.
That sounds fair enough, yeah.
Something about that, yes. And we look like we got Stephen's screen up, so it's over to you, Stephen. Away you go.
Okay, the Islands is a project that Michael Bulmer and Michael Bulmer from University of Queensland and James Baglin from RMIT have developed. And it's a virtual tool where you can collect data. It's free. Basically, no one can be hurt. There are, I think Michael was worried that some of his students were doing things with alcohol and, taking medications that they were looking for results and an effect, and I think it was getting a bit dangerous. So this is completely free, and I've got his email at the end of this quick PowerPoint, so if you'd like to email him, he'll give you instructions on how to be an administrator. So I'll just go through a couple of things. So it's great, as Brian said, for looking for research questions and writing reports, so you can plan investigation, you can sample the virtual population, and the results you get are realistic, so they're based on real data, even though the simulation is not real. But it's quite good because you can do a 1-year study in 28 days, so 1 week is like a season, so you can actually grow things as well. The Islanders, they sleep after 10 o'clock, so you can't actually do anything to them. You can take blood or you can inject them with things, but you can't make them go for a run. You can sleep deprive them if you're up before 10 and keep them awake. So you can do all these other sorts of studies, and they wake up after sunrise sometimes. Just when you do get confirmation that you can be an administrator, it's hidden away in this little island here with the red circle around it. So you can use a spreadsheet to add all your students in fairly quickly, and they can then start collecting data. The idea is that the students can open multiple browsers and collect lots of different bits of data. Just below that, there's the Academy, and there's lots of sample projects in that, and they're all hyperlinked, so there's a few pages. I've only taken one screenshot, but you can see there's projects that students have done from overseas. It's being used in the University of Minnesota, and you can look at what's been collected there. And there's also weather stations in each island. There's 3 main islands, so you can see if islanders run quicker at hotter latitudes and things like that, or you can just look at the weather data. There's rainfall data and everything. It's all simulated, and it's quite interesting to compare different locations. There's also a place where you can put in different combinations of fertiliser and grow things and get different yields, and then you can actually go out and do it for real with the real fertiliser and all that. So it's all based on scientific fact, and I'll just show you an example. If we go into a little town, so this is Hoffen, where the Hoff comes from, maybe not. If we go into that town, this is the little town that's circled, so it tells you how many people are in the town, and I'm going to house number 38, and there's my victim or person that I'm going to get some samples from. First thing you have to do, though, is get consent. So some of the islanders won't give you consent. They'll say no, so it's roughly 1 in 10 won't take part in your studies. So you can obtain consent by clicking on the link, and then for this particular islander I was just getting some blood serotonin, but you can see all the other types of tests that Michael Bulmer's added there. So you can do all these blood tests, you can get them to do an IQ test, a memory test, you can get them to empty their bladder, you can get them to take a non-alcoholic, an alcoholic drink. He keeps adding different tests to it, so there's a few more there. You can get them to eat chocolate, see if that has an effect on running 100 metres. You can inject them with adrenaline, you can give them placebos as well, and you can get them to do all these sorts of mental tasks, coordination things. You can even talk to them too. He's got a facility in there now where you can ask them questions, and some of them actually lie. So this is an example of getting some serotonin from this participant, and as the serotonin fills up the syringe, it's not actually live now, but that syringe will fill up so you can see how long it takes. So excuse me, it might take about 40 seconds to get the data, and then at the end of that time, if you go into the history over here, you can see how much serotonin is in his system before you get him to do a test. So there's the email there of Michael Bulmer. If you email him and say you'd like to register with the islands, you can sign up and get your students working on that. So I'll just go to the example that I did with the serotonin. So, and the report, as Brian said, this was an example of collecting some data, and basically only need a few students, and I had students collecting males and females as well to see if there was a difference between the serotonin levels in males and females. So, vigorous exercise. So the idea is measure their serotonin before, get them to go on I think it was 100 metre or 1 kilometre run. So that takes several minutes for them to do the run, and then measure the serotonin straight after that. So if you leave it too long, if you leave it over half an hour, it's like in the real world the serotonin has worn off. So basically you have to model this like there are alcohols and drinks that you can give them to. You might have to wait 15, 20 minutes for the effects of that to happen. So as an example, this is data from 20 different islanders, and I had their age and measured their serotonin before and after, and you can see the times there for the run. And first thing we look at is a box plot, and if I did the serotonin before and compared that to after, the difference is so vast that you can't see. I'll just show you what this looks like. If we go to add an X variable there, and if we looked at after, so actually what have I done? Sorry. Oh, that's okay. So I've got the serotonin before and after. So as Brian said, you can see this one is fairly symmetrical, maybe skewed a little bit to the right, and we have an outlier up here. If I measured the serotonin, oh, hello, I'm still on.
Yes, Stephen.
Okay, yep. That wasn't, I don't know what that was. So we can look at the serotonin before and after, so you can see there's definitely, after all 20 people have a little run, that the serotonin level increases, and then you can see if it's different, if there's a gender effect. So we can look at that, and it's just gone to the serotonin before, so I need to put in another screen because I want to do the serotonin after as well. So if I just do a split screen here and then just go through the same process again, and I want another box plot, and I want to add another variable, and oops, sorry, let's get back to that. And I want to add after there. Now the scale's not the same, so we need to get the same scale. I haven't got the effects of gender here either, so I need to bring that in. And I've got from 160 to 280. Oh, these are both before, so I need to click down here and change this to after. Now the scales are not the same, so I need to adjust my window so it goes roughly from 160 to about 310. So I'll do that on both. So if I go over to the menu and then go to window and go from 160 to 310, and then if I just do this top one, (160 to 310). Okay, so now we've got roughly the same scale, and as Brian said there, you can see there's a bit of a skew down here with the males. They were also skewed up here. The females up there, you can't see that too well. So the males are the orange and the females are the blue. So there's definitely an effect there with the serotonin, and you need to make sure you've got the same scale there so you can compare them. I'll just go to the other one, the bungee jumping. So this was
That looks
good, yeah. Which will result in the bigger adrenaline rush, a 25-metre bungee jump or a 50-metre jump, and most students will be able to tell you straight away that it should be the 50. And you could, once again, you could just do a random sample of 20 people, but if you select males and females, you can see there may be a difference with gender. So this is my spreadsheet of the data, and if you notice, the adrenaline before is only 32.9, and then over here I'm way up in the 1500s. If you're comparing the adrenaline before and after, the box plot of the before is just like a line because of the scaling. So I'm just going to look at comparing the 50 and the 25-metre jump. So if we did the 25 and turn that into a box plot, and then add an X variable, and we want the 50. So there's just the general difference. So there's no whisker in this one, and you can also, if you want to, look at the effects of gender as well, and do the same thing. This is only 25. I'll just quickly put in another window, and turn that into a box plot, and then add another X variable, and I haven't got the same window there. Sorry, I want gender here. So just click on gender. And once again, we haven't got the same scale, so this goes from 1,100 to 6,500, so I might just quickly do that. So if we go to Window, Settings, and then I'll just fix up this one. Oh, I don't think I did that one. Window Settings. Wait a sec. Adrenaline 2550. That one's okay. Sorry, I haven't done the right one. I'll just go back to that. And $5,000. Okay, so you can see from that the females go from a median of 2180 to 5,500. So the females actually have a bigger adrenaline rush, and therefore are probably more prone to scream compared to the males. And I think that's about it for me. That will do. I'll hand back to Jim.
Thanks, Stephen. Quite fascinating to see the sorts of data that you can get out of that simulator that you talked about there, the island. So, well worth looking at, I think, and Michael Bullman might find himself inundated with quite a few requests.
Yeah, he's just come back from long service, so...
Yes, I know, yes. I sent him a request the other day and he hasn't responded to it yet. Wonder why.
Yeah.
Anyway, we're now moving on to our third presenter, and it's quite amazing that we're actually sticking pretty closely to the times and the running schedule that we had, so we've done very, very well. So, Mel, it's over to you to talk and show us some of the STEM Behind Health activities.
Thanks very much, Jim. And thanks to Stephen. I hearing about the island the other night. I've just sent off my email a few moments ago to Michael to get access to that, and I've already got ideas of how I might use that in the classroom. So what I'm looking at tonight is another way of doing the applications with our 5-number summaries, and that is using the TI resources that are already written in the STEM Behind Health program. And I'll show you in a few moments how to access those. With the STEM Behind Health, or with any of your data comparisons, we tend to start, certainly I can only talk from here in Queensland, but we start looking at mean, median, mode, our central tendencies, early on, late primary school, and looking at grade 8, grade 9 sort of maths. And it's only when we then sort of get into maybe the range a little bit, but not much more than that, till we get to grade 9, grade 10. And students, I think, by that stage, having calculated the mean time after time after time, are sort of starting to say, well, why are we doing this? And I think we need to make sure that we are showing them practical and realistic ways that data is actually used and what we do with data to really let them know that, yes, maths is used every day, and there is just so much out there. I particularly like it. I'm teaching Year 10 Extension at my school at the moment, which is based around the 10 Accelerated Australian curriculum. As well as that, I'm teaching a Science Maths Academy Maths B Prep class, which is also based on the 10 Advanced curriculum, but I teach it with a lot more of the technology. The students have the TI-Nspires, and I like to do a lot of the hands-on work with them, so they really are seeing that application of all of the maths that we're teaching them. And so I like, with the data, to not only focus on your central tendencies, but get them looking at the range, looking at the 5-number summary, and then obviously the interquartile range, and as well start bringing in the standard deviation there so that they can really do a full data comparison. The activity that we're about to look at is an activity that my Year 10 Maths B Prep class have actually just completed as part of an assessment task, and I took 2 activities from the TI Stand Behind Health website and also got them to get some data from the Diabetes Australia website and do another comparison as well. So when I start looking at 5-number summaries, what I always like to do is to get them to compare 2 data sets. And this is one particular one where I've even put this question on assessment pieces in the past, where they can't really just use the mean, the median, and the mode to make a decision. As I explained to students, the whole idea of statistics, it's not just to calculate the mean, median, and mode, which they see in the classroom all the time, but it's to make decisions and to be able to justify or back up that decision. And also our big push here in our current senior curriculum, which, as many of you are probably aware, is changing in the next couple of years, but they need to also look at what assumptions have they made and how might those assumptions change the outcome of the results. So I've got here, and I'll just go into it, 2 small sets of data, and I've entered them into a list and spreadsheets page. Now, what the students are able to do is do the 5-number summary. In order to do that, they can choose to put that information just on their list and spreadsheets page. You go into menu, you go into statistics, stat calculations, and we're only looking at one variable, even though there's 2 data sets there, one variable, statistics. Now, what we're able to do is actually do the calculations on both runner A and runner B at the same time. We don't need to do those separately. So we do that by saying that there are 2 lists that it needs to get the data from, and I've called them runner A and runner B. So now it wants to know where is it getting the data from. So the first list it's going to get the data from is runner A, and my second list is going to go from runner B. The first result column being in B, I don't want it to put the data in B because that's where I've already got some data, so I'm just going to change this one, and I'll get it to drop it in C. And you can see here that we've now got our 2 data sets, and if we go across, we've got our 1 variable statistics on runner 1, and then our 1 variable statistics on runner 2. Now we can see here that the mean for both sets of data is 12.57, so if we're going to make a decision which runner we want to choose, the mean's not going to help us. If we go down a little bit further, both data sets have 10 values. The minimum of each, well, runner A is 12.1, runner B is 12. There's not a lot of difference there. You're talking 0.1 of a second. Continuing down, they've both got the same Q1, median Q4. Q3s are a little bit different. Sorry, median is 12.4. Q3s are a little bit different at 12.6 and 12.4, and then the maximum values are a bit different. As well as that, we can bring in the standard deviation. Looking at the numbers, it's still hard to make a decision. So as I've said to students, I say to students all the time, we want to look at a picture. It's often easier. So the data, I'm going to put runner A on there, And what I'm able to do, I will change that to a box plot by going menu and plot type.
Melissa, I'm just wondering if you could make that screen a little bigger, please.
Yep, definitely, sorry. I knew I forgot to do something. Thanks, Brian. So then also, I want to have both of my runners on there. So what I'm able to do, if I go into menu and this time go to the plot properties, I can add another X variable. And this is, Stephen showed it before, and Brian did have that up there before as well. But that's how you add in another X variable to have two plots. Somebody's phone's going off on it. Jim, can you still hear me?
Yeah, I can hear it. I don't know where it's coming from.
I'm not sure either. So I'll just keep going.
Oh, there, it stopped. Oh, no.
It came back.
So this is
That's better.
That's better. Whatever somebody did, we fixed it. So get the side-by-side box plots there for comparison. You are adding an extra X variable. So then we can look at talking about the two data sets, and both have got outliers here, but what I'd be getting students to look at here and what I'd be expecting from students is that they do in their reports a comparison that actually states the mean for each being the same, the median for each being close to the same with 12.4, 12.4, but then looking at, well, runner B here with a much smaller box is a much more consistent runner, although we do have those few outliers. Okay, so when we're doing reports, we need to teach the students that they need to be actually including the data value and within the report, but making that comparison and then making a decision that with a small box or with a symmetrical box, that what we've got there is a more consistent set of results and make decisions from that. So that's the first thing that I often look at. Now the second thing that I look at is a practical application as such. And one that I liked in particular, and if looking at my screen now on the education.ti website, and I'm looking at the US site here. So in the US website, you can change the sites to Australia and New Zealand, which I tend to use, except when I'm looking for the activities, the STEM activities that have been put together. You just need to go to the activities drop-down menu, and you've got your STEM behind Hollywood, STEM behind health, STEM behind NASA. And so STEM behind health is looking at research into a number of different diseases. One of them is to do with diabetes, and there's actually two activities there, and there's also one there now to do with cancer. So with these, you can download all the files as zip files, similar to Brian's file. You get a TI-Nspire activity file, you get a student worksheet, and you get teacher notes. So set up similarly to what Brian was showing before. What I've got open here now is the teacher notes. This also gives you little hints as you're going through as to what you could be doing. So it tells you roughly 1-2 minute lesson, etc. Sorry, 1 or 2 lessons, 45 minutes, going through the various screens. It gives a bit of background information, which I thought was interesting. There are questions within the file. So I took them out for the assessment piece and wrote it separately for my students. To be submitted, I didn't ask these particular questions, but I asked questions where they had to have read the data. But what I quite like, there's some interactives, and I will go into the file, which I've not managed to open up. And I've now got a problem whereby I can't remember where I saved it. Because we're running out of time, I'm not going to actually do that. Sorry about that. But having a look at it, there's interactives where they get some data. They go through again, and there's, on this particular one, pages 1.19 and 1.20, it actually talks about how they use statistics in the lab, which I thought was very interesting for the students to read from the point of view of it's not just the teacher telling them you need to do this, etc. Does a few basic calculations for mean. It then actually has some box plots, and in this one it has 3 box plots, and you need to make a decision. Now, this particular one, the blue box plot there is a control set. So looking at the replication rates, in this one they're looking at replication rates of cells to try and kill off some of the cells and increase the amount of insulin that the body is actually producing. So the control obviously don't get any medication. The orange one here gets drug 1, the red one gets drug 2, and you need to make a decision as to which is the best option. And the good thing as well is that they do talk about how scientists need to conduct a number of trials. So this data is actually based on 500 trials of each. So 500 sets of data for the controls, 500 sets of data for drug 1, and 500 sets of data for drug 2. So it's also looking at the fact that just doing an experiment once or twice is not going to give us a good set of results. You must replicate your experiments. And those are the things that students can be talking about in their assumptions, is I've only done this experiment twice and these are my results. I need to do my experiment 10, 15 times, etc., to get a more reliable set of results. It then goes through another simulation as well and making decisions. So, and this was, again, a question that I got my students to look at, whereby they're given the box plots and make a decision. You can see in the middle one there, drug 1, yes, it's got the highest replication rate, which is what you're looking for. However, it's also got one of the lower replication rates, and it is actually quite skewed. Is that an effective choice? What would be the best option? And then ask them a number of questions. So you can either use that as an in-class full lesson, or as I did, I took out and I cancelled or deleted out a number of the pages and I formed my assignment task for the students in a separate document around what I was looking for. It does give assessment ideas there. It does give you a link to the Diabetes Research Foundation. That is obviously an American one. You can go to Diabetes Australia and get data, which is what I also got my students to do. But certainly what I focus on with this and with the assignment is getting the students to really do the comparison and getting them in their reports to be talking about the minimum value of each of them, the maximum value of each of the data sets, the median of each of the data sets, how they compare. In this, looking again at the graph that I've got on screen at the moment, drug 1 and drug 2 have both got the same medians, so why would you choose drug 1 or choose drug 2? You've got to make sure in your report that you are discussing each of the statistics and using all of them collectively. So it's very much, I'm using it, as I said, in a Year 10 higher level class, and it's to get them to think about really discussing the statistics and really justifying their answers, their decisions with those statistics. So the STEM behind health there, as I said, if you go into STEM behind health, you get the red users information. There's the breast cancer one when good DNA goes bad. Diabetes, I also used in my particular assessment task the diabetes, type 1 diabetes, managing a critical ratio, and that was a good way to have the students looking at ratios and how they are used in reality, in real life. There's the STEM behind Hollywood range as well, and the one I'm also liking at the moment is the STEM behind NASA range. And I'm doing activities from this one, scaffolding them a fair bit, but using them at the moment with some primary school classes that I'm doing and using them to get ideas. So there's a number of things that the students can look at there with the activities that are on the site, looking at amounts of fuel and all that sort of thing. But that's getting slightly off topic. Our topic was looking at the box plots and how we're doing comparisons to 5-number summaries, which for us in Queensland is taught, as I said, we bring it in Year 9, Year 10. Our Maths A students do statistics, our Maths B students do statistics as well. So that's my part, and trying to stick to the time limit there. So
you're running well there, Mel. You got anything else just to finish off?
no, that was mine. So it is now back over to you, Jim.
Thank you. And I'll just share my screen so everybody else can see it. But I'm not sure if Brian's back with us or that
I'm
little bit
still
of
here, but I don't think you can hear me.
Sorry?
No, just touch again, Brian.
Oh, you can hear me now?
Yep.
I can hear.
I've gone in and out 3 times on the redialing. It booted me off and it's taken me back. Oh, that's nice. I'm pleased to be here at the end. And guys, that was right on the money. I really, really enjoyed those applications. It's tied together beautifully.
It
Really
does.
like
It's a really good set of things you've shown us tonight, folks. From Brian's introduction to the concepts and the understanding of 5-number summaries, and a couple of great sources of data for applications from Mel and Stephen. So thank you very, very much. I just want to run through a few little things just to finish off. As you'd be aware, at the end of these seminars, we are always interested in your feedback, so please take the time to complete the survey at the end of the event, and you will be contacted in a little while, with some information, including the PD certificate and the links to the files, or you know where to find them on the website anyway, and they'll be up there in a couple of days, and you'll be able to download the PowerPoints and the Inspire activities that were used in tonight's webinar. There's a lot of other services available. Brian's mentioned the Australian Curriculum Inspired or the Senior Curriculum Inspired. Some free tests up there. Other things, I want to skip through to one that's particularly interesting to me at the moment. Learn, Energize, Connect, these professional developments conducted by TI. There's a few coming up in Victoria, I think those places are, and of course there is one coming up in Cairns in Queensland for any Queensland viewers to this webinar, and following straight on to that we'll have the Queensland Maths Teachers Association Conference. So if you haven't been to one before, good place to go and spend some time in Cairns with us in the middle of winter. That just about wraps it up. If you've got follow-up questions, I'm sure the people at TI Australia would be glad to hear from you following up from this webinar over the next few days. So with that, Daisy, I might say thank you very much to our presenters tonight. Thanks, Brian, thanks, Mel, and thanks, Stephen, and say good night to everybody.
Thanks, Jim.
Cheers,
Thanks
Good
very
night.
much, Jim. Thanks, Brian. Thanks, Stephen.